Hi guys, my name is Lauren, technical trainer for Genesis Attachments. Today I'm going to take a few minutes to show you how to properly measure for adjustment plates in the lower jaw of a Genesis Shear. This particular model is a GXT 445, but the same thing applies across the entire Genesis Shear line. Before you get started, you want to make sure you're safe. You don't want to put your fingers anywhere where you might lose them. Second of all, if you've got an operator sitting in the operator's seat with the cylinder hooked up in this, you want to be mindful that he knows what the plan is and not to move it without your instruction to do so. Second of all, you want to make sure that your pivot group is tight. Measuring for adjustment plates doesn't do you any good if the upper jaw can move back and forth. That needs to be within spec. Third, the upper jaw should be able to move smoothly through the lower jaw without interference. That means it doesn't contact any of the lower jaw pockets, and it doesn't interfere with the auto guide puck above the pivot group. Once you've decided those things are good, you have to create a little bit of a game plan. And by that I mean you need to know where to measure. I laid this out with some X's so you can see where we would typically measure. And on all three of these plates, as well as the other one on this side. These two adjustment plates with these blades, we're going to be aiming for a 10 thousandths gap. These two up front that bypass the piercing tip, we're going to aim for a 15 thousandths gap, but we're also going to include a 20 thousandths shim on both sides for added adjustability. Piercing tips are a little bit more susceptible to thermal expansion. They travel further, they travel faster, so we have to account for the extra heat. You don't need specialized tools. We use snap gauges and dial calipers, or digital calipers, but you could do it with an inside micrometer, maybe even a depth mic if you got crafty. Now from the other side of the shear, you noted where I marked these, so I'm going to want to take a measurement at approximately that spot with the snap gauge, capture that dimension, and then measure it with the caliper. I have 2.155. If you'll notice, I wrote 2.155 here on the upper jaw. And our blades in this shear are 1.750 inches wide. So in order to come to an adjustment plate measurement, I need to subtract our blade width, which gives me 405, and then subtract my desired blade gap. I actually want 10, but I know by doing this several times that 12 is actually going to work well for me. My final dimension is 0.393. That's my adjustment plate cut measurement. Now on the other side, it's a little different because I'm going to want a larger, wider gap with an adjustment plate. This is the same process. I still want to measure the same way. I want to capture my dimension, and then I want to do my math. My gap here was 2.159. I have to subtract the blade width. I end up with 409. I want to subtract 20 thousandths for an additional shim. I end up with 389. And I also want to subtract 17 thousandths. I actually want 15, but I know that adding 2 will give me a little bit more perfect fit on the first try. So the dimension I want to cut to at this spot is 0.372. That's how I've marked it. You want to repeat this process at all 4 locations on this guide seat.
Alright, let's pause this video right here for a moment. When I was making this video, one thing that I failed to mention was the need for a clean out gap. And by a clean out gap, what I mean is the top edge of the lower jaw blades and the bottom edge of the upper jaw blades should be the closest point as the blades bypass. When the upper jaw continues to close, the blades should never get closer to one another than they are at that point, the point at which they would be making their cut. This allows for a little bit of extra clearance as the jaw continues to bypass, which will allow for additional debris, balling material, or perhaps dirt, which will limit the amount of friction and thermal expansion that will occur at the point beyond the cut. So you can see by my graphic here, the red area would be where the blades are relatively tight, and the blue area, they should be a little bit, have a little extra added clearance. That clearance should only be about 10 or 15 thousandths more than your desired blade gap, but it does need to be figured into your adjustment plate calculations. So if you were looking for a 10 thousandths blade gap and an extra 15 thousandths, you'd have to use 25 thousandths as your total adjustment number, not 10 or 12 as I describe here in this video. This additional cleanout gap space also needs to be figured on the guide side. So you would figure for additional space at the bottom of both guide blades, as well as for the primary and secondary lower jaw blades. No change would need to be made to the upper jaw blades or the piercing tips, as they are bolted in tight to the blade pockets. And now we can get back to the remainder of the video.
Once you've done that, you can repeat the process until you have all your measurements, and then you can transfer your dimensions to your print sheet. These can be a little bit confusing, so you want to make sure that you put them in the right location. A lot of times they can be identified by the chamfer that's marked on here, or the knockout hole. These used to be doweled years ago, but now they just use a knockout hole so you can have an aid when you're knocking the blades out of the lower jaw. Now for the speed of this video, I had already measured and laid this out. I marked my 4 points on here. I know that my actual measurement between the blade pocket and the upper jaw was 2.155. I could write that down and leave it alone if I wanted to, send it to us and we could take care of the adjustment for you. Or you could do your math and mark it at 0.393. You'd want to repeat the process for all 4 of those points. That would complete this adjustment plate measuring. Then it would be just up to the machine work. Once you've got that done and submitted, the adjustment plate is going to be machined on both sides. It's going to be flat on one side and tapered to the dimensions that you measured. It's also going to have chamfers, which should tell you exactly how it seats in the blade, the blade pocket, as well as the appropriate knockout hole. If you lay these out properly the first time, they should be almost drop in and bolt in, torque, and go to work, but a lot of times they require a little bit of adjustment. You'd want to take that off the back side. If you need to do a little sanding, sometimes marks on the adjustment plate will tell you where your contact area and the lower blade pockets are. We like to use fiber discs with rubber backing plates rather than hard grinding wheels. They're a little softer, easier to feather out, and don't gouge up the plate. If you have questions, please feel free to give us a call. We can be reached at 1-888-SHEAR-IT. Thank you.